All right, guys, another fun-filled, action-packed, flipped geometry classroom with your host, Coach Goo, or should I say Chef Goo, because I just made some fried rice that was like 10 times better than Panda Express. Panda Express's fried rice is garbage compared to Coach Goo's fried rice, and that is in no way because I'm Chinese. All right, so anyways, so today we're going to be starting a new topic, and this is everyone's favorite right here, okay? When people think about geometry, really they think about trigonometry, and that's what we're starting today. We're starting trigonometry. Oh my goodness. Here we go. Trigonometry. What is trigonometry, Coach Goo? Well, you see, young grasshoppers, trigonometry is the study of the relationships between the angles and the sides of a triangle. And these relationships are expressed as ratios. Now we've got 3 different ratios, and don't lose me here, but they are called sine, or we abbreviate sine, or we abbreviate it as sin, cosine, or we abbreviate it as cos, and tangent, which we abbreviate as tan, which is what I am, jacked and tan. All right, so let's take a look at what these actually even mean. So let's scroll it down a little bit. All right, so I'm gonna fill in these 3. First, you need to know what this is right here. What is this little oval with a line in it? What's that? That's not a pill from Dr. Mario, okay? That is called theta, and it is a Greek symbol we use to depict the angle that we're talking about, okay? So I'm gonna fill in this little chart right here, and then you guys fill it in as well. Alrighty, so let's see here. This is what these all mean. So on the sine of theta is gonna be the opposite side over the hypotenuse. The cosine of theta is going to be the adjacent side over the hypotenuse. And the tangent of theta is going to be the opposite side over the adjacent side. So let's use these 2 triangles because the sine and cosine and tangent really do depend on which angle you're actually looking from. So in this first triangle on the left, let's say the angle you're looking at, theta, is over here in the bottom right corner, okay? So that's the angle that we're talking about. So if that's the angle, where's the first of all, where's the hypotenuse? You should always be able to label a hypotenuse because it's right across from the right angle. The hypotenuse in this case is right over here. That's not how I spell it. Hypotenuse. There you go. Now look at my angle theta. Where's the opposite side from theta? The side that's across or opposite from theta. That would be over here. Boom. That's opposite of theta. So that's going to be the opposite side. And then where's adjacent? Adjacent means right next to. Now, we've already used the hypotenuse, so that means the adjacent side would have to be this bottom side in relation to theta. Okay? So that's where the opposite side, the adjacent side, and the hypotenuse would be if you're looking from that bottom right corner. But let's take a look at the exact same triangle, but say we're looking for theta in the top left corner right here. Once again, where's the hypotenuse? That didn't change. It's across from the right angle. Hypotenuse. But now, where's the opposite side in this case? Where's the side opposite from theta? Right, boom, straight across. Now the opposite side is over here on the bottom. And that leaves the adjacent side. Where's the adjacent side? Now the adjacent side, the one right next to the theta, is over here on this left side. So look at how the sides change depending on where you're looking from. In this first triangle on the left, we're looking from the bottom left. Yeah, that's my guy. Woo, he's not so happy because he's like, man, trigonometry. But the opposite side from where he is over there on the left side, and the adjacent side is on the bottom. But now over here, oh, here he is. He's on top of the world now, so he's kind of happy a little bit. The opposite side is on the bottom. Okay, remember he started from the bottom. Now he's here. Okay. So now the adjacent side is on the left side. So it changes depending on where you're looking from. All right, now we're gonna do some examples, okay? So over here, let's practice writing the appropriate ratio. I'm gonna show you how to actually write these ratios with your triangle that you have. So first of all, look at sine of r. So when they tell you sine of r, first, where's r? That's over here. So that means your theta is gonna be right there at r. Now remember, you can look above to see what you need to do, but sine is opposite over hypotenuse. So I'm gonna put O over H to let myself know. O over H. Where's the opposite side from R? The theta right there. It's gonna be over here. That's 12. So 12. Whoa. 12 is the opposite side, and then it's over the hypotenuse. The hypotenuse is always across from the right angle. So that's I'm gonna label these with little shorthand. Opposite, and then that leaves adjacent as has to be over here when my theta is in the top right. So 12 over, where's the hypotenuse? That's the 13. So the sine of r would be 12 over 13. Next, cosine of r. Cosine, remember, is adjacent over hypotenuse, h. Oh, whoops, I'm not supposed to write that there. Huh. It's a over h. Now look back at the picture. Where's my adjacent side? It's the 5. So 5 is going to be my adjacent over the hypotenuse, which was 13. So the cosine of r is 5 over 13, or cosine of r equals 5 over 13. And lastly, the tangent of r, remember tangent, look above, is opposite side over the adjacent side. Where's the opposite side here? It's on the bottom, it's 12. That's not the wrong color. 12. And then the adjacent side is going to be the 5. All right? So that's what the sine, cosine, and tangent would be of r. But look in the next example, we're doing it of s. Now we need to erase everything. We're looking for the sine, cosine, and tangent of s. So now our theta is going to be down here where s is, and our sides are going to change a little bit. The hypotenuse is still over here at 13. It's across the right angle, so that's the h. Okay, opposite. Where's the opposite side from the theta angle? Over here. That's going to be 5 now, so I'm going to write O for that. And adjacent is right next to the the theta, which is going to be over here at the 12. So the sides have changed. So what's the sine of S? Remember, sine is opposite over hypotenuse, so it's going to be 5. That's the opposite over the hypotenuse, which is 13. Next, cosine. Remember, cosine is adjacent over hypotenuse. Where's my adjacent side? It's 12, and the hypotenuse is 13. And lastly, the tangent is going to be opposite over adjacent. Where's the opposite side? It's 5, and the adjacent side is 12. And there we have it. That is how you're going to actually use these ratios to find your answers. Now this section right here in class, we're going to learn how to find these things with a calculator. It's quite simple. You just plug it into the calculator, but we'll do that in class. Scrolling onto the bottom right here, SOHCAHTOA. SOHCAHTOA, dudes. And what does SOHCAHTOA mean? This is a clever little trick to help you remember what each of the ratios mean. What does sine mean? What does cosine mean? What does tangent mean? So just say it with me, guys. SOHCAHTOA. 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 All right, so remember that in your head. Just plug that in your brain. SOHCAHTOA. What does that mean? I will now show you the abbreviation, what it stands for. So is sine, means opposite over the hypotenuse. Ka means cosine, and that equals the adjacent over the hypotenuse. And toa means tangent is the opposite over the adjacent. So SOHCAHTOA is a handy way to remember how to find the ratios. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So that concludes these notes. We'll do some practice in class, but guys, welcome to the world of trigonometry because we're about to really just get in there and get triggy with it. All right, see you next time. Peace.